Anthony Priscilla doing more sum and difference identities with my trig class. We're going to simplify a trigonometric expression. Simplify sine alpha plus beta minus sine alpha minus beta. Make sure you don't make that common mistake and just distribute the SIN, okay? This sure doesn't mean sine times, okay? This is a function of x, or a function of alpha and beta. Sine alpha plus beta minus sine alpha minus beta. I'm going to do this sort of color coding it. In blue, I'm going to write out sine alpha plus beta. I'll do it right down here. So in blue, I'm writing sine alpha plus beta. That's sine, cosine, same symbol, cosine, sine. Sine, cosine, cosine, sine, same symbol in the middle. I'll just sort of help you keep it straight. Here's this minus. I'm going to write in green right there. And in red, I'm going to write out sine alpha minus beta. So that would be sine, cosine, same symbol, cosine, sine. But the way I have it written right there isn't really correct. Why? Now, if we're going to subtract this, it means we need to subtract all of this red stuff. If I put this in parentheses here, does that sort of help you figure out what I'm trying to say you need to do there? What am I going to have to do with that green minus? Distribute it. So there should be a minus, and this red minus is about to become a plus. So I'm rewriting this, distributing that minus. And remember when I told you don't be dropping the angles? Make sure you're writing those angles. If you got into the habit of dropping the angles, no, don't write COS or SIN without an angle after it. So cosine alpha, cosine beta, plus cosine alpha, sine beta. Now distributing that minus, we would have a minus sine alpha cosine beta, and then negative, negative, that's going to be a plus cosine alpha sine beta. Hopefully some of this stuff is going to now either subtract out or combine. Let's see. I think something subtracts out. What's subtracting out here?
Sine alpha cosine.
Yeah, the sine alpha cosine beta minus sine alpha cosine beta. So we have cosine alpha sine beta plus cosine alpha sine beta. What's that going to give us? Can I combine those like terms? Yeah, the variable parts are all the same. Cosine alpha sine beta. So to combine them, you just add the numbers in front. There's a 1 there, an understood 1. So 1 cosine alpha sine beta plus 1 cosine alpha sine beta, that's going to be 2 cosine alpha sine beta. Oh, and which one was it? Oh, what's the difference between A and B? 2 cosine alpha. Oh, wait.
It's 2 cosines.
Yeah, it has 2 cosines. It's A. Okay. Any questions there? Let's see. How about this one here? Use identities to write the following expression as a function of W alone. Okay, and it's a tangent one. Tangent 30 degrees plus W. Well, hopefully you're not going to get too upset, but glancing through this, it looks like they did up rationalized denominators. Okay, just to have something to reference. I'm going to draw a unit circle right here. And this is just my thoughts. In my mind, I'm thinking, okay, at 30 degrees on the unit circle, what was that point of intersection there? Do you remember? Square root of 3 over 2, comma, 1/2. And why am I mentioning that? Well, we haven't used this tangent A plus B identity yet today, but so here's our first time to use it. It's going to be tangent first angle. On top, do I keep the same sign or change it? Same, plus tangent W. So it's tangent A plus tangent B over 1. Then change that sign, so minus, remember it's same over change, just like sine over cosine for tangent. 1 minus tangent 30 degrees times tangent W. Oh my gosh, is someone locked out of here? Oh, this is not, I'm sorry. Oh, let's not close it. Another hall noise than that happened. Yeah, okay, I'm sorry. That happens the next time you knock loud. So let's see. We need to know tangent 30 degrees, right? So I'm just thinking. This is just my thoughts here. Tangent 30 degrees. That is sine over cosine. So it would be 1/2 over the square root of 3 over 2. And how can I simplify that? Well, I'm not going to rationalize just because looking at the answers here, none of them rationalize. But I could rewrite this so it's not that complex fraction by multiplying above and below by what? 2. So for tangent 30 degrees, I'm just going to use a 1 over square root of 3. Why am I not rationalizing? Well, because I want my answer to look like one of these answer choices. And the answer choices here didn't rationalize. So plugging in 1 over the square root of 3, oh wow, is it just going to fall out pretty quickly there? In place of the tangent 30 degrees, we have 1 over the square root of 3. Then the green plus tangent W over 1 minus, in place of the tangent 30 degrees, that's what I'm doing, is replacing these tangent 30 degrees with 1 over the square root of 3. I have 1 over square root of 3 tangent W. And now if you just didn't like that square root of 3 in the bottom, what could I multiply above and below by that would, or at least if you don't like this complex fraction here, what could you multiply above and below by to get rid of that fraction within the fraction? Square root of 3. But I guess that whoever wrote this problem liked it like that because I'm thinking that's how the answer is written. Is it, which one, C? Is this it? Any questions there?